Distillation, simple and fractional. Distillation is a way to separate liquids from mixtures based on their different boiling points. There are two main types you need to know: simple distillation and fractional distillation. Simple distillation. Simple distillation is used when you want to separate a liquid from a mixture, especially if the liquid has a boiling point very different from the other substances in the mixture. For example, it is used to get pure water from seawater. Here's how it works. 1. The mixture is placed in a flask and heated. 2. The liquid with the lowest boiling point evaporates first. 3. The vapor travels through a condenser, which is cooled by water. As it cools, it turns back into a liquid and is collected in a separate container. 4. The substances with higher boiling points stay in the flask. Tips for simple distillation. Make sure water goes in at the bottom of the condenser and out at the top to fully fill it. This method works best when the boiling points are far apart. If they are too close, the liquids may mix again because both start evaporating. Fractional distillation. Fractional distillation is used when you need to separate several liquids with close boiling points. This is common in industry, for example, when separating crude oil into different fractions, but it can also be done in a lab. How it works. 1. Place the mixture in a flask and attach a fractionating column on top. Heat the mixture. 2. Liquids have different boiling points, so they evaporate at different temperatures. 3. The liquid with the lowest boiling point evaporates first. When the thermometer matches its boiling point, the vapor reaches the top of the column, passes into the condenser, and cools into a liquid. This liquid is collected. 4. Liquids with higher boiling points may also evaporate, but condense partway back down the column. 5. Once the first liquid is collected, raise the temperature to collect the next liquid in order of boiling point. Tip: the fractionating column works because it is cooler at the top. This allows liquids with higher boiling points to condense before they reach the top. Practice questions. Distillation. Question. A student tries to separate a mixture of ethanol, boiling point 78, and propanol, boiling point 97, using simple distillation. Why did it fail? Suggest another method. Ethanol and propanol have boiling points too close for simple distillation. Fractional distillation should be used instead. Butanoic acid has a boiling point of 164 and propanoic acid 141. During fractional distillation, which is collected first? Propanoic acid is collected first because it has the lower boiling point. Question. A mixture contains methanol 65, ethanol 78, and propanol 97. How could you separate them? Use fractional distillation. Heat the mixture gradually. Collect methanol first, then ethanol, then propanol according to their boiling points. History of the atom. Our understanding of the atom has changed over time, built on experiments and new evidence. The plum pudding model. John Dalton first said atoms were solid spheres, with each element made of a different type of sphere. Later, Thomson discovered electrons, showing atoms are not solid. He proposed the plum pudding model, where electrons are stuck inside a ball of positive charge. Tip: models are tools for scientists to predict and explain experiments. If a model fails to explain results, it must change. Rutherford and the nuclear model. Ernest Rutherford and Ernest Marsden conducted alpha particle scattering experiments. They fired positively charged particles at a thin gold sheet. Most particles passed straight through. Some bounced back. This showed atoms are mostly empty space with a tiny, dense, positively charged nucleus. Bohr's model. Rutherford's model left a problem. Electrons around the nucleus should collapse into it. Niels Bohr proposed that electrons orbit the nucleus at fixed distances called shells. His model explained many experiments and became closer to the modern model. Discovery of protons and neutrons. Rutherford's experiments showed the nucleus contains particles with the same charge as hydrogen nuclei, called protons. Later, James Chadwick discovered neutrons, neutral particles in the nucleus. Practice questions. History of atom. Who described atoms as solid spheres? John Dalton. Whose experiments provided evidence of neutrons? James Chadwick. Describe Rutherford and Marsden's alpha particle experiments and results. Why did this disprove the plum pudding model? They fired alpha particles at gold foil. Most passed through, some bounced back. This showed atoms have a dense, positively charged nucleus, not a uniform positive sphere as in the plum pudding model. Question: how did Bohr arrange electrons in the atom, and why was it accepted? Electrons orbit the nucleus in fixed shells. This explained experimental observations and solved the problem of electrons collapsing into the nucleus. Electronic structure. Electrons are arranged in shells around the nucleus. The first shell holds up to 2 electrons. The second shell holds up to 8. The third shell holds up to 8 for the first 20 elements. Electrons fill shells closest to the nucleus first. Steps to write electronic structures. 1. Find the number of electrons. 2. Fill the first shell with 2 electrons. 3. Fill the second shell with up to 8 electrons. 4. Fill the third shell with remaining electrons, up to 8. 5. Stop when all electrons are placed. Example: nitrogen has 7 electrons. First shell, 2. Second shell, 5. You can also write electronic structures numerically. Nitrogen, 2, 5. Argon, 2, 8, 8. Potassium, 2, 8, 8, 1. Calcium, 2, 8, 8, 2. Tip: Electrons prefer full shells, which is why atoms react to complete their outer shell. Practice questions. Electronic structure. Question. Another name for an electron shell. Energy level. Question. Max electrons in first shell. 2. Question. Max electrons in second shell. 8. Question. Max electrons in third shell. 8. Which shell fills first? The one closest to the nucleus. Question. Which element has electronic structure 2,4? Carbon. Which element has electronic structure 2,8,6? Oxygen. Question. Draw electronic structure of oxygen. First shell, 2 electrons. Second shell, 6 electrons. Question. Draw electronic structure of boron. First shell, 2. Second shell, 3. Question. Write electronic structure of phosphorus. 2, 8, 5. Write electronic structure of magnesium. 2, 8, 2.